Okay, welcome everybody. Tonight is going to be something a little new and different. Mark Michaelis is back again. We are on a quest to try and understand garbage collection in .NET. We had some questions come up, just how it works, the differences between .NET Core, .NET Framework, and so we are going to basically be playing around tonight and see what we can learn and see how much we can test something that we only have limited control over. So, Mark, welcome.
Thank you.
Well,
good to be here again.
Awesome. Okay, so I have done absolutely as little as humanly possible. I have a PowerShell script that literally prints hello world, and I ran a .NET new for a console project. So we've got pretty much nothing. I've got 2 hello world implementations, which is exciting.
That is exciting stuff.
The C# extension is recommended for this file. Actually, I should probably have that. So, don't mind me. I'm just clicking buttons. Okay, so where did you want to go first? Because you had sent me a list of like 4 things to try. What should we try?
I think the first thing is to see how the finalizer get called when the program shuts down in .NET Core. So if we go write a class, let's call it thing, perhaps. And for ease, you might want to consider putting both in the same file. Yeah, exactly.
Yeah, we don't need to bounce around. This is literally about as simple as possible.
Yeah.
I don't know if you're watching the Twitter chat. Megan says hello.
Hi, Megan.
So okay, so now we want.
I'm kind of surprised that Megan, decided to listen to us more. She's listened to us quite a bit already.
That is true. Well, hopefully not bore too many people.
So let's put a finalizer. Let's just go ahead and write out a message. So executing finalizer.
I assume we're talking just console, right?
Yes, that's great.
Thing be gone. You had a fancier phrase, but I can spell thing be gone. Executing's a big word.
I would hate to push your vocabulary to use words like executing and finalizer, so that's good enough for me.
Perfect.
And let's go ahead and declare a let's declare a method called do something.
Inside of thing?
No, sorry, inside main or outside of main. Well, we should try it in main because I think that's a more interesting problem to look at. So let's just go ahead and do it inside main.
Okay.
And go ahead and instantiate thing.
I'm trying to set up for a Dr. Seuss reference.
Yeah, I see. Does that mean we have to come up with another variable with maybe a name like thing2 maybe? Just
yes, that would be ideal.
Okay, good.
I try to prep my jokes in advance.
Uh-huh. I think that's good enough. Let's see what happens.
Oh, just compile and run.
Well, sure. I mean, we've got a finalizer. We've instantiated a thing. What's going to happen now?
Good question. So, something about .NET Run. That's not a good sign.
So, observation number 1, we have a finalizer, and we've instantiated a thing, and we would expect, under normal circumstances, that our thing would be disposed of.
So, let's see, .NET Core, finalizer does not appear to be called on shutdown. Right?
So that's a little bit disconcerting. Why don't we try put the instantiation inside another method? So let's write a do something method. Let's instantiate thing1 there. We could call it thing2 if you like. We'll just move that line down. Yep.
Yeah.
And now try it again.
Swing and a miss.
No worky. So the only other thing that might be worth trying is to change it to a framework project.
So rather than targeting .NET Core, so .NET 4.5?
I think .NET 4.5 is good. That sounds like a good number to me.
I'm just trying to go as old as possible. That's interesting.
We still got nothing. So according to the documentation,
Just out of curiosity, right? So public thing, right?
you want to make sure that we actually create this thing?
Right? Like, because for example, you'll note that one of us forgot to call do thing.
Oh my goodness, details.
So-
And I'm supposed to
so-
be the one. I'm not the one typing, so it has to be me that made that mistake.
Well, clearly, it is always the navigator's fault, never the driver.
That's true, unless I'm navigating. I mean, unless I'm the driving, then it's different.
Ooh, look at that. So now, thing be gone.
Okay, now let's change the project back to a
Netcore app.
core. Yeah. Now do the same thing.
Just for my sanity.
I think asking for your sanity is asking for a lot.
I realize that. That is a problem. So, inside of Netcore, we don't guarantee our finalizers.
This is exactly right. And I think, this is a fairly unknown, let's call it a secret feature. What should we call it?
Bug? Well, isn't that what we call undocumented features?
Yes, I guess. But I think it's only a bug if it wasn't intentional. And I think the team is well aware of this behavior, and it was not done without the awareness to put this in there. And so it's my understanding that it's intentionally, at least it is documented as being the fact that .NET Core does not guarantee that your finalizer will get called.
So, out of curiosity, where is that documentation page again, right? Also, there's universal agreement among the people chatting that it is either an odd feature, hated, or a secret.
So I can give you that.
I can try to hunt too,
Oh,
right?
I got it. How do I chat this with you? I got it.
Well, we're in a Skype call, so one would think that Skype would be able to send links.
Yeah, how about that one?
So, boom, that guy. So for those people playing along at home,
did I not send you the right link?
no, you did. This is the one you were looking for, correct?
Yeah.
Finalizers C# programming guide. No, it's just you sent it with the pound feedback, so it jumped me all the way to the end.
Oh, I apologize.
I forgive you.
Thank you. Hopefully that happens more than once today.
That you apologize or that I forgive you?
The latter.
Excellent. So something empty finalize should not be used. Yeah, so that line right there, in .NET Framework applications, but not in .NET Core applications, finalizers are also called when the program exits. I think we can conclusively say that line is true.
Yeah. Yes, indeed. So I think the reason why this is so intriguing to me is that we have this idea, and we've sort of, we've written about it, we've stated this, that assuming normal circumstances, other than the computer not being shut down or the debugger stopping the program, finalizers will always be executed sometime between when they go out of scope or when the application shuts down.
Yep.
And that's been true since C# 1.0, right? That's the rule. The finalizer will get called before the application shuts down. You don't know when, but it will happen. And clearly, we're saying that is no longer the case, and we've got very simple code to prove it.
Right, and so if we merely do, so let's just, okay, because now I'm curious, right? So we're going to go async main because I can. Oh, right. Something about lang version. Latest, because I don't want to think too hard. For those people watching, latest is a bad idea for most projects because it'll depend on what's installed on the system. What? Oh, could not be found. Okay, fine. Include it for me, please. Pretty please. So I'm curious if I do thing and then just do something like await task delay of a second, right? even in .NET Core, I would hope.
I don't think so, because what's going to trigger the finalizer? You're not putting pressure on memory.
I just sort of. Okay.
I mean, you're right. This is unpredictable circumstances, so I don't know.
Well, so GC.
Now I think you got a good chance.
So yes.
So hold on one second. GC collect runs synchronously, and it will stop the program. You won't need the delay if that works.
Good point. Try without the delay first.
Yes.
Because I'm wondering if I just give it enough time. Yeah. Okay. What? So GC collect. What was the namespace for garbage collection?
It's in. Thought it was in system. I guess not. Can't you just control enter? Control P?
I would love to, but it wants to introduce a local for GC collect, and that seems wrong. And I'm not used to coding without my fancy Visual Studio.
Well, we can switch, of course. I can tell you.
Hold up.
It's in system, like I said.
Then explain that to me.
I think it's going to have to take.
System
yeah,
GC.
That should be there.
Yeah, Jared, you are right on the mark, but I don't see.
It's .NET Core 3.1 GC. That should work.
I don't disagree. Okay, trying to run it anyway. Let's see what happens. Okay, so clearly OmniSharp is just out of its mind.
Yes, I think so. Try put system in front of it, see if that helps.
Really? Really, OmniSharp? Really? Clearly it does. And it also clearly doesn't actually force it to run. Right? So, because the one thing I was wanting to... Oh, hold on. Save your file first before you do that. The one thing I was wanting to see is a finalizer run. There we go.
Yes. Yeah, so that's actually really important.
Because I want to prove that finalizers work in .NET Core, right? Like, I
don't think you need your delay statement. I think that should work. I find it interesting that using PowerShell commenting there, but okay. I'm actually kind of surprised to see you using a pound to do PowerShell commenting.
I know. I was doing scripting earlier, and it unfortunately penetrated my fingers.
What's your warning? Oh,
I did it. I now have an async main without a.
So I got it. I understand.
But okay, so the GC collect did tell the thing, please go and clean up, and it said, okay, sure, I got nothing better to do.
Yeah, and the rule about GC collect, it will run for every finalizer that is in the finalization queue. So it does force finalization to happen, and as long as nothing's holding onto that object, you should be good. But the idea that we would have to call GC collect at the exit of every program, is that a viable approach? Maybe. Unless, of course, you got something holding on to it. And so the big concern here is, would it be okay to have a standard that says always call system.gc collect, which obviously Microsoft chose not to do automatically. But if you do, and you've got something that is still something still pointing to it, something still in scope, then it doesn't matter that you call GC's collect, because that thing doesn't go out of scope until the program exits. So if you had, for example, this is a static variable, you still wouldn't run the finalizer.
Yeah, but isn't there isn't there a concurrent GC too? Wouldn't that?
It's not going to help you because.
No, but I'm not thinking it would help. I'm thinking it would hurt, right? If you called GC collect and there was a concurrent garbage collection, like that would clean up most things. But what about something that gets like promoted to like a large object heap or something, right? Doesn't that like it wouldn't?
It's not good. So if you have something like an object that's resurrected or something like that, it doesn't really change. I don't think you're introducing unnecessary complexity. I don't think it matters.
Okay.
As long as the object has a reference to it, it will not get cleaned up by the finalizer.
Okay. So let me ask one other dumb question then. So the finalizer doesn't get called, but when does it actually matter, right? Like,
So this is the important part about finalization. Remember that finalizer is not used to manage memory.
yeah.
Only used to manage resources that are not managed by .NET. So, the example that I like to use, which is not a bad example, which is a bad example because there's other ways to do this, is, hey, what if I have something that I created, like a very large temporary file, and I want to make sure that file gets deleted before the application shuts down. Now, there are rules. You can actually create an event on a new file so that it gets shut down automatically when the stream is closed. And it'd be interesting to look at the code to find out if that's actually using a finalizer, but that's beside the point right now. The idea here is that you want something to happen when the application shuts down so that whatever it was doing or consuming or using no longer is being consumed.
So that makes sense. And that kind of, because Jared asked the question, what are some examples of finalizers that you'd want to run prior to an app shutdown? And I think that plays sort of right into that.
Yeah, I mean,
I could also think of like a process too, right? Like something that's it would have to be something that lives outside of your app, something that lives at a system level.
Right.
A socket too, I would imagine, but I
think sockets are handled by safe handles, so I don't know.
Oh, they are probably well. Like I don't doubt that a socket probably has its own finalizer, but if I can't guarantee that actually gets called.
So how about a resource? How about a mutex?
Yeah.
A mutex is something that should work across processes, to do things like make sure you don't run a process more than X number of times or something like that.
Yes.
But the idea is you got to make sure you clean up that mutex when you shut down the process. Otherwise, it's going to continue to prevent other things from running.
Yes. Yes. And I actually want to check real quick. So, because I believe sorry for everybody who was used to the dark theme. I am curious. Okay, so mutex derives from wait handle, which I assume. Let's go core CLR implementation. That isn't going to help me. Try this one. I'm looking to see if this guy actually has a finalizer somewhere. Right? Because wait handle, I would assume.
It implements iDisposable.
Right. But that's the cooperative finalization. There's nothing directly, there is no finalizer directly on mutex. But I suppose if I had an object that took out a mutex, I would want to make sure that it was cleaned up, right? Because this guy is disposable, I want to implement the iDispose pattern, right? The iDispose pattern involves a finalizer.
Right.
And therefore, I want to make sure my finalizer actually works.
Correct.
That seems mostly reasonable, right?
Again, I don't think we need to specify what it is that we're trying to do. It's just the idea that this is not.
Right.
It's
the
not
idea that there is
what
something.
we know to be the case, right?
Yeah.
And it's reasonable for us to come up with even imaginary examples. And, as I say, it could be a file, it could be a distributed connection.
I am really curious now, right? So now that you've gotten me on this, private read only, and this might end up hosing my system. So
Well, I wonder if you don't want to consider trying to finish out the example without the complexity and then add in things like mutexes.
Well, sort of what I want to see though is I want to see a mutex stick around outside the life of my app.
Yes.
Right?
Yes.
Like I want to get bit. Like I want to show the absolute worst case. Why is this a major problem for me? Right? Because that's ultimately what I am looking for.
You want to give it a name, right?
Well, that's what I was looking for. Where is the attach the name bit to it? Is it a constructor? There's something about it, and I don't remember exactly where it is. Mutex Boolean string. Initially owned string name. That's what I want. So true.
Yeah, I suspect this cleans itself up, but I could be wrong.
Well, but I've clearly got a case where I can break this, right?
Yes, I agree.
So I want to run this, not see this guy get called because I'm clearly not cleaning this up, right? And actually, just proof is in the pudding. So mutex dispose, the thing I should do, right?
Yes.
So if I do this, I expect it to not get disposed. Let me just make sure I am core still. Yeah, great. Everyone's happy. All right, and I'm going to make my warning go away because I don't like seeing lots of yellow text. Okay, so I don't expect it to get cleaned up. And then on my next run, I expect it to blow up in my face. Right? My process is gone.
Yes.
And now, go boom.
Let's take a...
Something's not working the way I expect.
Why do you not think that mutex cleans up after itself?
Well, no, so I don't think the mutex cleans up after itself. I think the process whacks it. Because the operating system, when it...
Why don't you do this? Why don't you put two mutex? Why don't you create two mutexes with the same name just to verify that we get the expected behavior?
That seems reasonable.
You might want to change the name of your variable, though. Your field. Field.
Right. So something like that. So Jared, the Boolean is the initially owned property because you can create a mutex and not own it. The type thing already contains a definition for, you should save your file before you try to call .NET Run on it.
So you should be able to do an F5, control F5, in fact.
Yeah, but it ran and this clearly didn't break, so that's... Okay, I should actually look at this because this is clearly something that... wait one, release mutex. That's probably the problem. The managed object doesn't matter. Got it.
Wait, what's called and release mutex?
So the I think I want it not initially owned, and I want mutex wait one, right?
Yes.
And then I want mutex release mutex. Let my mutex go. Okay.
Assume that dispose calls release mutex, but yes.
So that should work. And this should hang.
I am not surprised that it's not hanging, and I can't imagine a circumstances where you'd want it to.
I agree. It still bothers me on the way that mutex is working. I feel like I should be... Because you're supposed to be able to check and see it. Well,
you see, it works for inter-process communication. That's exactly what it's designed for.
Yeah, and the process is dead.
Where you want it to allow it to keep it alive. So the fact that the process handles this is not surprising to me.
That is fair. That is also disappointing. Okay.
Wait, you're disappointed that it behaves the way you want it to?
Well, I'm disappointed that it protects me from shooting myself in the foot. Sometimes I want to be able to shoot myself in the foot.
That's exactly what I'm hearing you say. I just want to make sure we're speaking clearly. Yes. Okay, so...
Okay, carry on.
So now the question that we want to ask ourselves is, well, what way do we make sure this finalizer will get called? And we've already got one obvious. We can call system.gccollect, but if the object is referenced, then gccollect will not succeed. And we can go ahead and prove that. So let's go have a static variable, go ahead and assign thing to that static variable, and I would just move your declaration, or however you want to do it. You going to do another one? How are you going to do it? Okay, that's fine.
right?
Yep, great. So now at this point, you call it GC collect. There's still a reference to the thing. So GC collect doesn't succeed in shutting down my, or calling my finalizer.
So try again. And then proof being in the pudding, if I take this out, I should see it get cleaned up. Okay. So it works as expected.
Yes, but not as wanted.
Meh.
Well, I don't think we want to take on responsibility. Imagine the size of your program. We don't want to take on the idea that, oh, GC collect is a viable way to solve this problem.
I don't disagree. GC collect is a stopgap problem.
It is a very easy way to do it, but it's not going to be reliably cleaning up. So the proposed solution for this is actually to call is to register for the process exit event.
Okay.
So presumably you do that inside your constructor.
Well, I would assume that I do it inside of main, right?
No, I would do it inside the constructor for thing. Because you might write this object in a different library. You may not even have a main.
Okay. Is this on the process object?
It's on app domain, I think.
We have a problem then, don't we?
I think app domain does have a process exit on it.
I don't doubt it, but not
Core.
in .NET Core 3.
Okay, maybe it's on process exit. One second, let me check.
I was going to say, the app domain class got highly limited. Yeah, so there is a process exit, right?
It's only on process? Okay, that's fine. Yeah, you're right.
Well, no, it lives on the app domain thingy. Big scary warning, yada, yada, yada. Yada, 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 big scary warning. So, app domain, current domain, domain unloaded.
Yeah, okay.
Why process exit? Okay.
And so now you're going to have to set up a close method because you can't call your finalizer. So you're going to have to go separate out your dispose pattern and,
All right, so.
Yep.
Something akin to that. Console. Right line. And we think that works.
So if works means we expect that sweep it under the rug is going to get called, the answer is yes, but we still don't expect that finalizer to get called.
Because of this.
Right, or because we don't have GC collect. We're not calling GC collect anyway, so it shouldn't matter whether you have that or not.
Okay, well let's just eliminate and have as few variables flying at the same time as possible.
By the way, as we do this, one of the things that's really interesting about it is testing is really hard. There's no way to test besides running a process and going through the exit. So if you're going to write a unit test for this, you actually have to have a unit test that goes and runs a process.
Yeah.
So it's
there would be some people who would dispute the unit portion of that test.
I don't think you have a choice. In fact, I think that is the only way to do this because you're actually trying to verify that it runs before exit. And the other thing that this raises is the fact that app domains are not sort of first-class citizens in .NET Core, so you can't run this in an app domain. The only app domain you have is your current one. You can't instantiate a new app domain.
Really? Then what's the create domain button do?
I don't think that works. I think it gives you an error and tells it does not work in .NET Core. Give it a try. This is a great example, I think. This is a great example of an API that shows up in order to be .NET Standard compatible, but in actual fact doesn't exist. I'm going by recollection, by memory here, so I could be wrong, but I believe that that's what happens.
So you don't think I can even get a new one?
I don't think so. Try it.
Oh, platform not supported exception.
Which, by the way, I mean, this is a whole nother issue in itself. Like, the fact that you would only know this, you basically lose the ability to program with IntelliSense. I mean, IntelliSense is going to lead you the wrong way in this particular scenario.
You mean because somebody might do app domain dot? Like,
well, yeah, exactly,
like I did? And went,
they might
hey,
have
look.
just gone ahead and converted an existing project, but they won't know this problem until they actually go ahead and run it. And it's a bit disconcerting to me that you have this create method. And obviously there's a tension between being, compile compatible but not runtime compatible.
That's true. Though I will say most of the time when people are using app domains, it's because they're doing some sort of like plug-in dynamic assembly loading bit. And .NET Core has an alternate API for that, which I think is called assembly load context.
Yes, but I don't think that's the point that I'm trying to make here is IntelliSense will lead you down the wrong way, and you will not know this unless you have a unit test or you run all your code.
Run all my code. That sounds simple enough.
Yeah, and I feel like, yeah, it's a little bit scary. It's disconcerting, I think, is a better word.
It's fair.
Anyway, we don't need to focus on that part. So what we have now is an example. We've actually called exit. We've not gone ahead and got an app domain, but we've registered for the event. And did we run this yet?
Yeah. So this one here, this guy here actually...
It worked. It worked, yes. Okay.
Yeah. So we swept it under the rug. Problem's gone.
So it's interesting now where we're at. We're now going to go process exit. But if we go ahead and call GC collect and we don't have a reference to it, ideally that would mean that this object would disappear by the finalizer, correct?
If we call GC collect and we don't... So correct.
So now go ahead and put the GC collect in there. Now we would be relying on the finalizer to get invoked.
Correct. So for those people unfamiliar with the GC, when the thing falls out of scope, ultimately when the garbage collector runs, it follows the root references and looks for things that are still referenced, and anything that's not referenced gets marked and put in a queue. Then it gets cleaned up, right? And that second step of then it gets cleaned up is when this guy gets invoked.
Exactly. And there's a separate thread running, and when it runs, it actually stops all threads in the process to go ahead and do the GC cleanup. But when you call system.gc to collect, you're actually given the ability to direct the runtime about when you think it should run.
Right.
This hasn't always been available as deterministic, but now I think in .NET Core it's deterministic.
Really?
That's my experience, and I think that's what the documentation for collect says. If you look at that, I was going to say,
I thought it was because collect, as I've always understood it, is a request to the GC to say, "Pretty please."
I believe in .NET Core, the documentation says differently, but let's check it.
Yeah. So blah blah blah.
Right there at the top, it says forces immediate garbage collection of all generations.
Where are you seeing that?
Right at with the description of the method. The very beginning. Go at the top. Go to the top.
Oh, perform a collection.
Forces an immediate garbage collection of all generations, right below where it says collect.
Yeah. Okay.
It seems pretty dogmatic, I guess. Is what I would say.
So, this is bothering me that. This also bothers me. Sometimes I feel like the documentation has been changed, and this this drop down doesn't reflect the version changes.
Yeah, why don't you change it to .NET Framework 1.0?
How about 1.1?
It would be scary because this was not true in 1.0. I'm pretty sure.
So 1.1 still has the same verbiage here.
Yeah, and what I don't know is which one changed, right? Has it always been that way? I don't know.
Yeah, something in the back of my mind is telling me that this hasn't always been a guarantee and that it's a request.
I'm agreeing with you 100%. Completely, that's my assertion, it was not. It was a request.
I might go poking through the docs repo and see, because this stuff is open source and you can hunt the history. I have a feeling that there's one source and they don't keep different versions for different bits here, right?
Yeah.
That's my hunch.
Yeah. I am agreeing with you on this one. And my recollection is that It's not. It has not always been deterministic.
Well, so that seems very obvious in that it would say GC go now, clean up all the stuff, do the thing.
So anyway, so the point being here is let's go run a GC collect. Now you expect the finalizer to be gold. Let's see if it actually is.
Nope.
So.
Oh, hold on
yes,
though.
Exactly. Yes, exactly.
I was going to say, there's an implicit this capture here.
Yes, exactly. So the scary thing about this is the recommended way to do this is to go ahead and set up an event that calls process exit that will now make sure your object gets called. But the very fact that you go ahead and create that reference to process exit is now meaning it never ends up in the finalization queue because something's pointing to it. So it can't get cleaned up.
So for those people who are missing it, there's an implicit this dot right here, which means this delegate that's being created holds on to a reference of this thing instance, and that delegate gets put on the list of delegates to get invoked for this event, which is a static event. So effectively, we have a static referencing our instance, which would be why this guy never gets called.
That's exactly right. So
hold on. I want to try something else. Right? Break the implicit capture.
Fair enough. But now you're not doing it inside the object.
Minor details.
My point is your object's not getting cleaned up.
Yeah, there it goes.
Yes, exactly.
So you get rid of the implicit capture
of
the instance, and now it works. I just have lost my reference to the instance.
Yes, exactly.
Which is sort of the thing that I needed to clean up in the first place.
Yes. So what now is interesting is what happened if we used a weak reference? And is it possible to use a weak reference to a delegate?
That's an interesting idea. So let's do this. So I think what you can get away with, right, is this. So thing ref, right? And I do var myself gets new weak reference of thing. I'll give it myself, right? And then I will let my delegate capture the weak reference.
Yes.
And I'll pass it in here.
This is exactly
Sweep it
right.
under the rug. And oh, I learned something yesterday or today. All my days. This is valid.
Yeah, I would have mentioned that to you. I had this.
And that is valid.
I won't mention any names, but I had an editor for my book, and his initials. His initials are the first letter of Kevin, and the first letter of boss. That's what his initials are. And he mentioned this and asked me to correct the code and wondered why I was doing this. And there is a reason that you want to go do this.
Sigh.
But I won't mention any names.
Okay, so out thing foo, right? So
you got to call the method. You got to call it.
What do you mean?
You want to call. I guess you don't have cleanup anymore. Is that what you're saying?
So I'm leaving cleanup as static, and passing this through, right, as a weak ref. I mean, I could do a private void instance cleanup, right? If we want to prove that we can act on the instance, right?
Yeah, let's get it working, and then I'll talk about some ideas for refactoring it, because I don't like the idea of us having to have the static method. But it may not be possible to avoid.
Yeah, so
okay. Yes, that's great. But I think if we went and declared the static method inside the, well, anyway, let's try it. It's good.
yeah, so it is very interesting. So one thing is falling out of scope. Oh, we've got a GC clean or a GC collect. Let's get rid of that. Okay, so now the thing's alive. We can get into here, right? Because the only reason we put the GC collect on here is to make sure that is to prove out the capturing.
The thing being gone isn't getting being called.
What? Well,
Thing
right.
be gone.
What would call this finalizer? Nothing's going to call it, right? I think the idea of what we're talking about.
Oh yeah, I guess that's fine because we're
Right.
saying we have to get. That's exactly what we expect. You're right.
Right. We're expecting that ultimately what ends up happening is it's something like here.
That's where you should call instance cleanup. Yes, exactly. Now that's
Yes,
exactly right.
though thing be right, but it's important to note that if you call an instance method in here, you can guarantee nothing about your managed references anymore.
So explain what you mean by that.
The order of cleanup isn't deterministic, right?
You don't care about that.
Well, but say I wanted to say hypothetically I had a mutex field here, right? If I tried to do something like mutex dispose, this would be bad.
Well, it is. So you mutex question dispose, and you should be doing that anyway.
So remember though, this falls into the iDisposable pattern, right? How you get your
Right. They should be reentrant. All dispose methods should be reentrant.
agreed, but in general, when you do your dispose method, you have a dispose that takes in a bool, and you only get rid of you only touch your managed references if that boolean is true, because and you call it with false from your finalizer, so that you know whether you can actually trust your managed references or not.
Yeah, I don't. So I agree with everything you're saying, but I think the way that I would make sure that you use that it's reentrant is not just to rely on that boolean, to actually go ahead and reset the variables to null, so that you actually have a marker other than what somebody calls you with.
I could understand that. That would make sense.
So by specifying in your mutex, you do the question mark period, you know that it hasn't been cleaned up or it has cleaned up.
So you expect something, the cleanup ends up looking something like this, right?
Yes.
Gets ugly for trying to use read-only, but meh.
Yeah, in actual fact, because you assume that they implemented mutex to be reentrant, I think you can still call dispose directly. So I think that actually works because assuming they wrote it correctly to allow dispose to be reentrant, even if dispose is being called, you can call it again.
I guess my thought is this little period right here scares me.
But we're talking about memory management. The object is still around.
I am still around, but I can't guarantee anything I reference is.
You can guarantee its reference. You just can't guarantee that it's the dispose method has or hasn't been called.
I can guarantee that a managed. So here, let's be.
If there's still a reference to it, the object is not out of scope, and it can be called.
So you're telling me I should be able to do thing to instance cleanup here. Pretend like that says dispose.
Yes.
I can't decide if I believe you or not.
Oh, I don't see why you would start now. But remember, right, we're talking about memory management. There's never a time where when an object goes out of scope does it become null.
Never a time an object goes out of scope and becomes null.
It goes out of scope, the memory manager just cleans it up. If you still have the ability to call something on it, it is not null. Because there's a reference to it.
Something in the back of my mind is telling me that there's something wrong with that. Right? Free manage objects, blah, blah, blah. Because the order in which garbage collection destroys managed objects during finalization is not defined. Calling this dispose overload.
But you're conflating. Is that a word? You're conflating the resource management with the memory management. You're looking at those two concepts the same. I don't see, as long as disposable is always reentrant, the object still exists.
Okay, I might make us actually hack out this example then at some point to prove to me that it's okay. Because it still is bothering me, because the whole point of this is so that you know inside of this method whether you came from a finalizer or not.
Yeah, I think to do this, what we're doing completely, we need to go ahead and add dispose. But we've still got a couple things to prove out, I believe.
Okay, well, I will stop then. Carry forward.
Well, I just want to look at the code. Let's go back to the code and just review that. We've got a weak reference, but I think we've sort of added a bit of complexity here that I'm not sure we want. So if we were trying to code this the simplest way, I think we need to have a close or cleanup method that's an instance method. And I don't know if we want to have the static cleanup. That seems like it's. Can we maybe put that?
Oh yeah, we can clean that up. So real quick, I will clean this up and get rid of the static one. Megan has a question about why does dispose need to be reentrant?
Because it's not predictable who has called it when. If two objects refer to something, and you don't know what order they're being called by the finalizer. Two objects may call dispose themselves, and you don't know. You don't know which one's already called it. So it doesn't need to be the best practice is just do this. But it is possible that two objects are going to call dispose on the dispose method. The other thing that can happen is there's the concept of resurrection. Kevin, can you remember the details on this? You can actually resurrect an object.
Yep. Yes, you can. You can make zombies in C#, and it is awesome. And you should never, ever do it. Bad.
This is not advisable.
But it is totally awesome.
But it is a good example of if an object can be resurrected, why dispose may end up being called multiple times.
Let's see. So I can get away with it. Cameron points out that in this context, awesome means terrible. But it's so cool. Cameron, you know you've always wanted to have your own zombie object army. I am giving you that chance. Let's see. So I'm going to, because I'm getting a little too carried away with my messages, I think these need to be a little clearer. I
would put the method name inside your message, so we always know what is being called.
The method name inside my method. The problem is I'm inside of a delegate.
Name inside your message.
What?
The name of the method that the message exists in, I would always put that name there so you know. Otherwise, we're losing track of which message is in which method.
I don't disagree, but what name would you like me to put inside of an anonymous delegate invoked from a constructor?
Anonymous delegate invoked from a constructor? It doesn't matter. Give it a name. Who cares? Give it a variable name. Go ahead and write it as a method, in fact.
So here's the thing, though. By writing it as a method, I now have the static versus instance problem, right? Like, I need to be clear on what it's capturing over, which is part of the anonymous delegate. Then I don't have to worry about it.
That's fair.
I mean, I could do it as a static local function.
Well, remember that all that's going to do is going to go. It's still going to foist it into the IL, right?
Force it into the IL.
Foist it. That method is still going to exist in the IL as an instance method, correct?
It
so what's the difference?
But it'll be on a a hidden inner class at this point, and it won't capture over anything.
I couldn't remember whether it's on a hidden inner class or is on this class itself.
I can double check, but I'm fairly confident they get their own hidden inner classes. Okay, so if we run
I
this,
just couldn't remember.
okay, so cleans up instance, so the instance stayed alive, which is what we expect given the lack of a GC, right? And if I turn the GC on, I expect it the other half of my if statement. Which is exactly what happens, right? So I can force myself into either half of this if statement based upon whether I call GC collect or not. Okay. It does sort of make me want to write some sort of fancy extension method on this, or helper. This feels like something very, very genericizable.
Well, and so that's the interesting part about this. How do we go ahead and write use the full finalization pattern? The full finalization pattern, we should have dispose, which goes and obviously deregisters from GC. I mean, that whole thing. You shouldn't really be implementing finalizers without a dispose.
Yes, I would agree. I cannot think of a single situation where I've created a finalizer where the object was not iDisposable.
In fact, I would say the coding guidelines are that they should all go together. If you have a dispose method, you should always have a finalizer, and if you have a finalizer, you should always have a dispose method. I don't know of any exceptions. That
is fair. So anything else we want to test along this path before?
I think you've covered all the scenarios I knew about. The most interesting one to me was the fact that when you registered with process exit, you had to do it with a weak reference.
Yeah, because this bites you all the time in WPF. Like the number of times I've had people ask questions about, what's going on? Why do I have this memory leak? Very consistently, I just hunt for plus equals. It's very like the C# team is wonderful that they've significantly improved the code you write to register. Right? They got it down to 2 characters, and
yes.
And the problem being is that people don't understand how much code gets generated by those 2 characters.
Oh my goodness. Well, actually, no, those 2 characters aren't getting, it's not that those generate that much. The process exit class or the method that when you create the event is what generates tons of code.
That's true.
So it's not actually the plus equals because that's literally just an assignment.
Right.
Of a delegate. The process exit declared as an event, that's what generates tons of code.
Yeah. There's a comment that the difference between awesome and terrible is shipping. And I'm okay with that definition because I have shipped stuff like this. Okay, so do we want to go down the iDisposable path now? Is that where we think we go next?
The only part that I think is left remaining here is what is the general pattern that we want for implementing finalizers and disposables, assuming they both together, let's just call it the dispose pattern.
Right, so first assumption, you're coding in .NET Core, right? Because
I don't know if we want to make a rule that's different. I think you want to do the same regardless.
Well, but does this API exist?
Which API?
The process exit. Here's my question. Like, I don't mind being different, but does that exist in like 4.6?
Well, just change your build. Just change your project.
Oh, that's a better test, isn't it?
I believe the answer is yes.
Okay, so API exists. This is about to get really ugly.
Well, that's why,
even with the helper, this is I'm just envisioning a particular project I have where there's a lot of finalizers due to some pointer horrendousness that may be getting done, and
Hypothetically speaking.
hypothetically speaking,
Right,
no one would
right.
ever do something crazy like
No,
that.
of course, no, of course. But in actual fact, I would say in those pointer scenarios, can't you rely on safe handles?
Not always, because I'm not always responsible for making those. Like I can sort of wrap things in safe handles, but a lot of times I'm getting the pointer back passed to me and then I'm sending it somewhere else. So
Yeah.
I can kind of do it, but ultimately I still have to manage it. Right?
Yeah, but if you're sending it somewhere else, they're going to have references to it and stuff. I don't know.
Yeah,
It just seems like to me you want to use safe handle as much as possible in the pointer case. I mean, that's what safe handle is designed for.
I do completely agree. Completely agree. Just in our case, I don't think it's always possible.
We shouldn't do it now, but I'd be curious to understand what scenario you have that you can't use a safe handle for a pointer.
That is fair. So not to derail us too much, but when we get to the iDisposable, I am curious about Ienumerable to go along with it.
Explain?
Ienumerable derives from it.
Well, of course.
Okay. I'm just so we're
so
aware.
does
That means that
so
anything we
does
put here
async-
is going to affect enumerables.
So does iasync enumerable, and for that matter, there's now an iasync disposable.
Agreed. Again, this is about to get very, very ugly.
I don't think so.
Okay.
I mean, what you're having to we're basically trying to refactor this code so we can sort two objects. At the end of the day, what we want to do is we want to have a thing and we have another thing, and we want to be able to implement the dispose pattern without writing 1,000 lines of code. Like that's the goal.
So what you're saying is we have thing 1 and thing 2, and we have to clean up a mess.
Yes, exactly.
Of all the hats I have sitting next to me, I don't have the right one for this moment. Which is really disappointing.
I'm so sorry.
Add that to my list. I need a cat in the hat.
Or just a thing 1 and a thing 2 shirt.
That's true. Okay, so we are going to do this. So we're going to start here, right? So can I cheat real quick? Private static void right line.
When you say cheat, did you mean can I go ahead and call resharper and have it generate my dispose method?
No, I'm just getting really annoyed of typing all of this out every time.
I
and so I'm just going to.
Yes, this is exactly right.
I'm going to horrendously cheat. Let's see. Name. Oh, that would be bad. Boom. Okay, so now I just do right line. I don't know, empty string. Ooh, better.
Can you call right line without anything?
I can as soon as I do this. Boom. What are you squawking about my color member name? Go at it. There we go. Okay. Now, less thinking. More awesome. Okay, so that gets rid of that. And I think I get rid of here. And instead of instance cleanup, we're going to call dispose instead. I realize this is not the correct dispose pattern. We'll get there in a moment. Right? Clean that up. We no longer need Mark. I'm really curious what this is.
Right? Okay, got it.
Okay. Cool. I think that works, right? So we have a GC collect. So we come in here, we see the instantiation. I'm getting rid of hello world because that's just adding to my noise, right? We see my constructor gets called, new thing, finalize gets called, thing be gone because we fell out of scope, and GC collect forced it to kick off. We then hit process exit, came in, weak reference no longer has a reference, so weak ref dead. Also realizing that that isn't using my new method. I'm curious what this thing reports. Yeah, constructor. Good to know. I wasn't sure what caller member name was going to be there.
It's interesting that it did the same thing for finalize. The column name in finalize is finalize.
Yes, yes. That one I was aware of because the you can actually get at, what is it, this.
What happens if you have a method called finalize?
Pretty sure it doesn't allow it, but let's check.
What? Because you have a finalizer.
Introducing a finalize method can interfere with destructor invocation.
And that's an error, not a warning, right?
No idea.
Well, compile it. Do a build.
Do a run. I'm lazy. Boom. Yeah, so short version, that guy's going to gen 1. This guy now conflicts. You have to break it for overload resolution. So.
Got it. Yeah, no, it's fine.
Yeah.
You shouldn't have finalizers and a method name finalize. I think it's a reasonable rule.
I agree. And it very accurately warns you that you're doing something bad and then blows up. So. Okay.
So the key thing here that we want to be aware of is your registration with a req reference.
Yep.
Is there anything else that needs to be refactored?
Well, part of me really wants to do something more like, I don't know. Right? I kind of want that.
Right. That's what I'm saying, refactor. That's what I meant. If you want to refactor everything inside your constructor.
Class.
iDisposable, static.
Name this iDisposable?
No. What if you had a static extension method that took an iDisposable?
That's what I'm thinking this is going to do, right?
Okay, then we agree.
Because we're now iDisposable, so we can do this.
So I would call it just disposable. The class. Register for finalize? I don't know. It's it's good enough for now. We don't need.
Yeah, I'm a little torn on using the word finalize because it seems to imply something about the finalizer, right?
Well, isn't that exactly what it should imply?
Well, but we're not going to invoke the finalizer.
No, it's register for finalizer, not invoke the finalizer.
Fair. Let's see. This becomes iDisposable.
Maybe it's register dispose for finalize with finalizer. I don't know.
Okay. Wow, I cannot type. Let's try that again. Console. Okay, and this thing becomes disposable. Right, so that now doesn't look quite as ugly. Let's just make sure it still works. Finalize thing be gone, weak reference dead. Clear that, toggle the other case. Okay. It appears we are falling down both cases of our if.
And in actual fact, do we need to ever test the system.collect method? Do we ever have to try the system.gc. Oh, I guess because we want to make sure the finalizer is invoked.
Yeah, that's mostly a sanity check to make sure Kevin hasn't botched something.
Can you do, you can't call collect on a specific object. I'm just wondering if we can do this without having to run the process twice.
No, you cannot do collect on a specific object, but for those people who want to know how to make zombies, let's see. System, GC.
Oh, you know what you're missing? You're missing the cancel finalization.
Yeah, that's when we get to the full dispose, right? Because re-register for finalize.
Suppress finalize.
Yes. Where is it?
It's right there.
Boom. Yeah. So you can take yourself out of the queue, right? So if you suppress finalize, that second step of the GC where it goes through and calls your finalizer, yeah, that method says don't do that. Okay, so let's actually keep going then, right? So the other thing that's worth noting is I don't think we can the other problem with trying to do this completely generically is the same reason why there's not a completely generic dispose implementation, because there's 4 cases, right?
Sorry, Kevin, why are we not calling GC suppress?
From right here?
If dispose gets called, GC suppress should be called.
Okay. Yes, I will fix this, because this is really what the full dispose implementation should look like, right? So this becomes dispose true, right? This guy becomes dispose false, right? And then this becomes dispose bool disposing. We need a private member.
Why the heck they don't create dispose? iDispose will have a second method on it. Hey, you know what we should do? We should go ahead and define an interface default member. Microsoft should define an interface default member called on iDisposable.
Oh dear heavens! I can imagine what that would do. Oh dear heavens. Right? So this looks something like this.
But that code is the same every time.
Say what again?
Your dispose that takes a variable is the same every time.
It is, but the key bit is the difference. Like, there's a reason there's 4 separate sections on this implementing, right? And inside of Visual Studio, you can now generate. Yay, they finally copied what ReSharper's had for a while.
I understand.
Right? Is you can now just say auto-gen me up an iDispose implementation, and it'll give you something. I think the default one, well, that's not quite right. It gens up a lot of code and comments out a lot of code, because you'll note that in some of these cases, they don't have a finalizer. Right? You don't need a finalizer in all cases.
Why not? I don't agree.
You don't need a finalizer if there's no unmanaged objects.
Then why do you need dispose?
So that you can clean up your managed stuff.
Why do you need to clean up your managed stuff? That's what the GC does.
Not if you want it deterministic.
Why? I'm not following.
Well, for example...
Scenario, you want to set things to null?
No, file handle. I want to make sure it's closed when I'm done with it.
File handles handle themselves.
Well, so they will clean up when the GC cleans them up. But if I want to make sure I release my file handle when I'm done with it, I need to actually wrap it into using, right? So that dispose gets invoked.
Yeah, exactly. But you still want a finalizer so that if you forget, it gets invoked.
Still want a finalizer so that if it gets invoked.
Okay, so let's just hold. Let me restate this. So what you're saying is, I've got an object that has got its own finalizer on it. Therefore, if I instantiate it, I don't need to worry about invoking its finalizer or using. I just need to worry about using dispose.
Correct. If you aren't not directly doing the unmanaged stuff on your own, you don't need to care. Right? It's when you are dealing with unmanaged objects.
I understand. What I'm trying to understand is why. If we're trying to clarify is why do you need dispose? Why do you implement iDispose?
Why do you implement iDispose? Well, so take your temp file case, right?
Yeah, it's because when you go out of scope, you want to make sure it gets cleaned up.
Yeah.
You want to support the dispose pattern on your object to be able to clean up the other object that supports the dispose pattern.
Sorry, big bright white screen for a moment. I'll let that fire up. Resharper's going to have to think about what it's done. But I want to show the default. Oh, wow, that is tiny. Let's make that bigger. Because the generated pattern that they have is actually... Oh, this is going to be Resharper's, isn't it? Oh, I need the one without Resharper.
Does control period not work?
So it does. The problem is Resharper hijacks it. And I have to turn Resharper off to see it.
I don't think I've ever seen you do this. This is going to be quite an experience.
Turn Resharper off?
Yeah.
Well, it's not exactly a challenge, but...
That's not my point. It goes against religion, so it's a challenge for you.
Hey, I only have it turned on one of my computers, so I actually see both sides, and it annoys me. That's not what I want. Where are you, Resharper? I might come back to this at a later point and gen it up. The default one that it generates is actually rather nice in the way that it comments everything out, right? But it'll gen one up for you with a finalizer, but the finalizer's commented out because they realize that most people probably are generating iDisposable without needing unmanaged stuff. Resharper is so old school. Just use writer. Ah, yes.
I'm best guessing that was Cameron.
No, that's the shocking part. I have a few coworkers who are very much writer fans. And I'm very tempted to actually go that direction. Resharper is slowly starting to feel really big and bulky. And I've got a machine that can handle Resharper, and there are times where it's just slow, and it's not resource limited. Cameron, yes, there are dozens of you writer users.
Okay, I've just pasted, I don't know if this paste is going to come through. I just pasted the code inside the chat window.
Oh, when it generated it?
Yeah.
Oh, thank you. So I'll go paste it up here, right? So it genned up something that looks like this. Yeah, that looks better. So let's see. So it generates a Boolean flag to know if it's been disposed, right? Because if it's been disposed, do nothing, set it to true, right? My if statement's inverted, but okay, sure. It does generate the finalizer, right? Yeah, so you'll note it's very explicitly.
What it doesn't do is register for process exit. What's the deal with that? Come on.
Well, bear in mind, I think we only need to guarantee the process exit in the managed case, right? Or in the unmanaged case. And this is clearly commented out because you only need it for unmanaged resources.
Fair enough.
Yeah. So, and then tells you, here's where you put the managed stuff. Here's where you put the unmanaged stuff. You should null out large fields because that is actually, helpful, right? Like you were telling me to do it before. This to take you out of the finalizer queue that the GC is going to run on, right? So, but again, only do this if the finalizer's overridden. Only override the finalizer if you have unmanaged objects.
This is suppress finalizer and you don't have a finalizer.
Say again?
What if you call GC suppress finalizer and you don't have a finalizer?
That's a good question. I imagine it's just wasteful.
Well, sure, but okay.
Anyway, okay. So worthwhile pattern. Anyway, so here we are. We have a finalizer, so we're making some sweeping assumptions about what we have, but huzzah. Right? So if we're disposing, we get rid of our managed stuff. I don't know. Right line, remove managed stuff, right? And then right line, remove unmanaged stuff. Boom. Right?
Well, I think that's it, right?
Look good to me. Let's see if it works. Let's see. So we created a new thing. Finalize was invoked. Dispose removed the unmanaged stuff without removing the managed stuff. And then the weak ref was dead, so GC is turned on. Yeah. And if we turn GC off, we should see the other side of that if. So constructor, dispose got called, remove managed stuff, remove unmanaged stuff.
Nice.
So it actually did properly clean it up.
So you know it'd be interesting is to instantiate it after you call system.collect, because we should be able to then replicate this whole thing without running the process twice. So instantiate it once, call GC collect, and then instantiate it again. And that way we only need one process.
Oh, so I can hit both sides, right?
Yes.
I don't think that works.
Looks good to me.
Try that again. So we create thing, right? Finalizer gets invoked, thing be gone, right? Dispose, remove unmanaged.
Hold on. When did we create two things?
Do thing.
Okay, I'm just surprised that we didn't see the finalize message before we created the second thing.
Yeah, that's a good point. It now makes me go back to my original statement. GC collect is not a command, it's a request. Request just may be denied.
Yeah.
Because that seems to indicate I've clearly put something there that's not there anymore.
And we don't have a reference to it?
No?
No, I know. I'm just trying to figure this out.
I'm literally creating it up and throwing it away.
Right. No, that's why. Hence my point. Right. I think this is showing that the documentation is wrong.
Correct. That is correct. And I think Keith seems to agree that this is the GC collect is a request, not a command. Garbage collector gets to tell you, nah, not interested, I'm busy, I'll come back later. No, your room's not that dirty. I'm not getting the vacuum out just because you got a little speck of dirt down there.
Is there anything we can do to force it? It worked before when we just had one object. We don't know what order it took.
Well, the thing is, we forced it before, and then we dropped out of main. Right?
So what if we put right lines?
I think there's a significant difference.
What if we put right lines? What if we put right lines before and after GC collect?
Hang on, real quick. Private static. I can type static. Int instance count. Right? Private int ID gets interlocked increment ref instance count.
Why do you need to do the interlocked?
Because I'm paranoid about threads.
Yeah, but you only got one. You're paranoid about the GC thread?
I'm telling you, I'm paranoid about threads.
You're not instantiating anything on two different threads. The GC may write a different thread, but that's not going to change your instance count. Are you decrementing instance count?
So GC wait for pending finalizers to wait. Ahaha. Thank you, Keith.
That is the second method. Yes, I knew there was a
Boom.
second one. Thank you.
And then because OmniSharp clearly can't figure it out, it's system. It's right there. It's right there. Okay, let's try that. Now we theoretically get the order that you expect.
Yeah, there was a second method.
Hey, look at that.
Yes, thank you. I knew there was a second one. I forgot about it. Thank you.
Yes. So let's turn that off just to prove a point. Yeah. And now we
now we got one process that proves both issues, so we don't need to go ahead and run the process twice, which was a pain.
Let's see. Is there a way to globally trap when the GC collect things, or do you have to instrument all dispose methods? So, in general, I guess my question would be, why do you want to globally trap when the GC collects things? So there's a lot of like performance and memory management tools that can tie into that level of stuff. Those are fairly low-level APIs. In general, you don't want to try and control the GC. The GC usually, like, the garbage collector in .NET is probably one of the things that has received some of the most performance optimizations over the years of the entire runtime, followed closely by system.string. You can correct me if I'm wrong, Mark, but at least that would be my perception, is those are probably the areas where the most time and energy has gone into optimizing. Because at this point, the .NET GC is ridiculously performant.
Yes, I'd agree with that.
Okay, so now we're back into our happy state where things run, we wait for pending finalizers, everything works nicely.
I think we're good. I think we've proven what we wanted to prove.
Proven that disposing sucks.
Is there a way to do this? There's just no way to refactor out dispose, is there?
So there's not.
That's what we're going to do. Could we create either an abstract class or an abstract interface?
You're going to have to explain, create an interface that does what?
That does the dispose pattern.
Oh, with like a default interface implementation?
Uh-huh, yeah.
Oh, that's an interesting and creepily... I hate the idea, but we're going to do it anyway.
Okay.
Public...
Say why you hate it.
Because, one, I universally dislike default interface members because... Yuck.
What kind of argument is that? I think this might be a great example of why you want a default interface member.
Yeah, sorry. So just to answer the question, finding things that stay pinned, I agree that you shouldn't end up with too many objects that need it. And then the finding things that stay pinned, I would imagine that you don't want to try to do something like that at runtime. That's what the memory management debugging tools are for. So the performance tool inside of Visual Studio, Redgate's tool, dot memory, etc. All of those, I would say, are probably better solutions if you're wanting to track down the stuff that's pinned.
Where are you chatting on this? Because I'm not seeing the chat. What am I missing? Oh, you're on Twitch. Sorry.
Yes, I have an extra window that you don't have, but you can go to Twitch and see it yourself as well.
I was so busy looking at the screen, I wasn't looking at Twitch.
Sorry, that's why I just keep jumping in on you every time. Because I try to pay attention every so often. Okay, so we can do a default interface. Yeah, so I do think it would be very important to call out when I would expect that this interface actually would get used, right?
But let me just be clear why I'm looking to do this. To implement the dispose pattern, there's only one method that is custom.
And by only one that's custom, you're referring to this guy here, right?
Correct.
Okay.
And in fact, we could go ahead we could actually go ahead and have abstract versions of dispose unmanaged and dispose managed. And then we could actually implement dispose.
Wait, what? Oh, I dispose managed, I dispose unmanaged.
Yes. And yeah, so you could do that. And furthermore, you could mark him, and this is going to sound bizarre, you could mark him as protected because they should never be called directly.
So, agreed. So bear in mind, the other metric that the dispose stuff generates for is whether you expect to derive from the class or not, right?
Yeah, that does.
Those are the two cases of how you end up with 4 permutations of
yeah,
do I derive or not, or do I have unmanaged or not?
So let's look at the case without derivation and see if we can do it further. But I just think that it should be possible to implement dispose. Let's look at the non-derived case to start.
Okay, so I assume you're anticipating something like this, right?
Yes.
Okay, so that goes there. I'm apparently quickly going to become a meme. And what are we we actually want to go through?
I think you want to implement dispose, and dispose it takes a boolean, and you want to have abstract members for unmanaged cleanup and managed cleanup.
So what you're suggesting then is, well, disposed managed, right? Void dispose unmanaged. So we'll deal with protection levels later because that's one thing I see that's different about this, right? Right? And then because there is no way this is going to be a bad idea. I can't get away with this, can I?
Why is that lowercase d?
Say that again?
Why does your field begin with a lowercase?
Because I'm typing quickly.
Okay, just
and no
checking.
analyzers.
Just checking. Well, you've got a whole audience, I think. They qualify as analyzers.
Well, based on the number of stuff I've gotten away with tonight, I don't know if I would quite go that far. So we do. So first problem. Well, hang on. You can do private fields. Yeah. So Keith, I would agree with you in general for .NET, though I'm going to post a link real quick. There is a long-standing debate, and you will find, so the IntelliTech coding standards actually invert that for Pascal case, which is the subtle inside joke that's being referenced there. Let's see, I can get away with this, can't I? Trying to remember how to do this.
I'm not seeing where your type. Oh, there it is. What are you trying to do?
I'm trying to figure out how I can actually implement this, right? Because I want this level of implementation, right? The problem is this requires state.
What if you did as an abstract class to start, and then we can change it later?
So yeah, that works, but then you come up with the other problems as well with that, right? If you can't effectively tack this onto something.
Well, I agree. I said we can change it later. Let's make it an abstract class to start.
Okay. Fixing that name then. Something like that. Something like that. I'm just going to use this because boom, 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 boom. Right, and then this becomes right? So we're now protected abstract. See, and I still can't spell. Yeah, Keith, IntelliTech is who both Mark and I work for. Mark won't admit it, but he's the head honcho person.
You are just trouble.
I was trying to work on my way of having to apologize and get forgiven a second time. You got to set these things up well in advance.
Okay. Just remember, I know where you work.
Don't worry, I'm not planning on going into the office anytime soon.
I don't know. Does that mean we're not going to get this thing lifted? What the heck?
Okay, so something akin to that, right?
No, you can't make that private.
Why?
Oh, yeah, that one you can.
Who's going to call it? You should go through the
right.
public
That
dispose.
one, you're right. You're right. I was looking at the wrong one. I agree.
And I mean, technically, if I'm going to keep if this is going to be an abstract class, right? I now can actually get around to the other side where I do dispose false. Semicolons are hard. System, GC, suppress, finalize, this, right? And heck, if I'm an abstract class, I can keep going, right? So, protected, cleanup, this, register for cleanup. Right?
Yes.
So, on one hand, now I get really nice, and I don't need any of this. In fact, I don't even need the... Shoot, I should just get rid of all the things.
I think you might put the extension method back up there.
Say again?
We can probably move your extension method into there as well.
Yeah, that would be... Well, no, you can't, because that would make it a static class.
Not if you put it as a subclass or something like that. Nobody else needs it. Anyway, don't worry about it. It's fine.
Yes, I think you run into I think what I'm going to do, though, real quick, just for my own sanity.
Subclass was the wrong word. I meant nested class, but anyway.
All right, because I want this, and I want to do... I kind of just want to have right lines everywhere, right? Because I kind of just want to prove where I'm at. And yeah. So now all this guy comes with is implement abstract class, and I'm actually going to expose this guy just so I can abuse him a little bit further. All right, so paste, figure out how to type, optional. All right, okay, go, do all the things. Wait, do I hear a train in the background?
You do hear a train in the background.
Go home.
Yes.
I did not recognize that wall, and I probably should have. Okay,
You
so
don't have
construct.
showers and beds here, right?
It's true.
Actually, bed's probably a euphemism.
Hammock.
Hammock is a better word.
Yes. So constructor 1 was called, finalize was called, dispose was called, dispose unmanaged was called. Kind of all makes sense, right? Then constructor 2 was called, weak ref was dead. This is why we include the method name so that... Where the heck is... Oh, that's right. There. Dispose 2 was called. Dispose 2 was called twice. No, it wasn't. This is because I have a right line here too, right? I don't really want that dispose. Because one was called with the dispose without the Boolean, then one was called the dispose with the Boolean, then managed, then unmanaged. Okay. Are you watching chat now? Do I need to forward the jokes verbally?
I am now on the thing.
Excellent.
Who is that?
Okay, so abstract base works, right? But it has all of the problems of being an abstract base class.
Yeah, so now we make it an interface.
Okay. So here's the part where I think it starts to quickly fall apart. I'm going to leave the abstract class, and I'm going to write the interface side by side.
Oh, for sure. No, I think you should leave the abstract class.
I clean up. And you will also be I disposable, right?
In fact, the way to do this eventually would be to have both.
I don't doubt that. I'm just questioning if we can actually get away with everything in the interface. Right?
You have how many instance members? Just one, right? You only have one field, right?
I have a single field, but this one doesn't technically. Well, do we count this one?
Yeah, that's the only one you have.
I technically have this little ID thing, but that one's inconsequential. That one's just for output.
We didn't need that. We don't need that in our. Yeah.
No, this one we don't need. This is just so that Kevin could have nice output.
So I think the only one you need is disposed.
Right. So here's the problem. Here's problem number one. I'm pretty sure I can't get away with this.
Why not? You just got to implement in the base class, the derived class.
That feels yucky, but okay. And I'm just going to grab all of this then, right?
You can't have a finalizer.
Yeah, that's the other fun one, right? Because I mentioned a second ago that the let's see. So dispose we can actually give a default implementation to, right?
Yes.
Let's see. Oh, but
you copied that, right? You didn't
yeah, I copied it. I believe I have to do Isn't it like this? I have to do explicit implementation to have
Because why?
Because if I do this, I'm hiding the base member, and that's not what I want.
How do you get around that?
By doing an explicit implementation. Right? Because now it knows how to resolve this. It knows that I
understand.
actually saying go to the base. Which I think makes sense-ish. All right, so this guy we said we don't need anymore. This guy.
Wait, which one did you delete?
Sorry, I whacked this. I'll move it down. I had a second copy of the property.
Okay, that's what I was checking. You had a second copy. Got it.
Yep, so we don't need the right line. That doesn't matter. We do need these. Let's see. We cannot have a constructor. That is not a thing. Right? And these things no longer need to be bad. Right? We want the implementer of the interface to get a disposed managed and disposed unmanaged because I don't know what you got.
Do we want them to... What did you have them declared as before? Were they protected?
Yeah, they were protected abstract. And that's the only other thing I'm not...
Do you sure you don't want them again to be protected abstract?
You can't use abstract on an interface member.
You can use abstract on a... implemented... There's... What's the rule? Oh my goodness.
I think
you can definitely use protected. I think...
Because you can put a protection modifier if you're going to do a default implementation, right?
Yes. But you can't if it's not. Okay, fair enough.
Right. Yeah, which makes it difficult.
Well, in actual fact, this is what we want. That's what we want to force people to implement.
Right. I'm not a huge fan of the API that effectively exposes methods that somebody could theoretically call, but yuck. Right? Like somebody implements this interface.
Can you not declare those as protected
I don't believe
and
so.
virtual? Wait, Kevin, why don't you declare them as... You can do that?
So we're going to test this because I don't know. I'm fairly confident. You can.
Yeah. So that's what my point is. You don't need to expose them publicly.
Okay. That makes me feel mildly better because I would not want somebody to be able to just get a hold of this.
That is the goal.
All right. So does this mean I can do this?
No, you can't do that. You can do it protected, but not private.
Because it's not marked as abstract, external, or partial.
No, you can't do a private property because it doesn't generate the property. You're requiring the derived class to implement it. That should be protected.
I know the implementation. I want an auto property. I want a switch that I go on, off, on, off.
That should be protected. There you go.
Well,
really? Do other people call whether it's disposed method?
actually, can I get away with that? No. Abstract properties cannot have private accessors. I feel like I want them to.
No, you don't. You don't want to have data in your interface.
I realize that. What I want is multiple inheritance.
Okay. Well, you're getting pretty close to multiple inheritance with this interface. And so the last thing does that work? Are we working?
So we are, so we're in a running state, I believe, at this point. But, right. So so we've got thing, right? Let's do, because I'm going to keep my running joke going, right? Right, because I feel like I want to have a compare and contrast moment.
Yes. And eventually, what I'd like to do is I'd like to refactor cleanup to implement iCleanup.
I could understand that. Huh. Remind me to look that up. This is why default interface implementations suck. See that? See that?
No, I don't. What's wrong?
Protected set, public set. I don't like protection modifiers in interfaces. They just do things wrong.
Wait, sorry, I didn't follow what you're saying. What was the problem?
Interface, protected set.
I'm not seeing something. Maybe your mouse is behind or something. Okay.
Protected set, right?
Yeah.
Public set. Right? Because technically that implements the interface. I get why it works. It just makes me unhappy. Okay. So the other thing then that this guy has to be able to do, right, is hypothetically, he now needs to know that if I implement the interface, I need to clean up, right? So I need to call dispose, which apparently might need to indicate a problem, right? I've already got a protection problem here. And then GC suppress finalize this. And we'll make OmniSharp happy.
Is dispose marked as protected in the base in the interface? Why can't you call dispose then? No, you don't want to do that. You want to make it public though.
I'm sorry, I want to do what?
The dispose method. Oh, this is the one that takes a Boolean.
Yeah, because the finalizer now needs to invoke it, right? Ideally passing a false. I can't just call into the public one.
Okay, so you're going to have a problem here. If you mark that as protected, I don't think you can invoke it.
I don't disagree. Largely because the compiler tells me so.
Yeah, this is one of the weirdest, most non-intuitive things about protected. You can declare a method, but you can't invoke it. So just want to make sure that everyone who's seeing this is what's going on. So inside your thing2, you have declared a dispose method. Well, I guess you didn't, but you can't invoke it.
Right. I can't get to the protected the protected member on my interface.
Right. And in fact, if you overwrite it inside thing2, you overwrite dispose, you still can't call it.
That's exciting. Protection modifiers are awesome on interfaces.
It's worth demonstrating this.
This is why when I was asked about default interface members yesterday, my answer was don't use them.
Yesterday?
Yes. I was having fun with coding standard stuff.
Oh, I see. Oh, I get it. And we don't want to. Is there a way to do this?
I don't think you can get a reasonable implementation just abusing an interface.
Hold on, I'm not satisfied yet. Is the only issue we have that we can't call dispose?
We can do it. There.
My screen's frozen. What am I seeing?
Don't you worry. Don't you worry. There is new hotness that dropped. I'm trying to see if there's a dark mode, and I don't see it. I'm sure it's probably hiding around here. .NET 5, the preview that dropped this week has source generators. You aren't smiling. Source generators are supposed to make you do this.
You're just trying to get at having to write IL.
It's so beautiful.
But before you do this, Kevin, I want to see if we can do it without this.
Oh, I don't think I'm going to pull it tonight because I still have to download it. And I'll point out it's 10 to 11, so.
There's only one issue, right? And the only issue we have is that we can't call dispose. Is that correct?
So I have the issue of I can't get access to my dispose. I don't like this Boolean having to be declared like this, but I could live with it. It would make me unhappy.
Yeah, that you got to live with that.
This is just a weird thing, right? Because my interface wants state.
I agree. You got to live with that one. I can't get it.
The other thing that it doesn't give me is it doesn't give me the auto register in the constructor like this guy gave me, right?
No, I understand. But what I basically want to get to is if this works and you get your cleanup class to implement the interface, then the user has either choice. So if we can solve the dispose method here, essentially the whole we've got a good solution because you can either derive from cleanup or implement iCleanup.
Correct.
So the only problem that we need to solve is how do you call dispose?
And Kelly, you're absolutely correct. I've already been looking at ways of making them awesome. If Mark hadn't messaged me, there will probably be a stream where it's all about me just wanting to play with source generators. Because they look really cool. So, as far as actually being able to invoke this, though, right? Like
you can. There's a way to do it. I just want to make sure that's the only problem before we solve it.
Okay. So, So I don't doubt that we can make it so that we can invoke it. My only fear is I would not want to expose it such that someone outside of me could call it. Right?
Okay.
Because that would, if someone not me is able to call dispose and pass a Boolean from outside, that seems very, very bad.
Okay, I think that's fair. Are there any other issues besides this, though?
These guys have the same protection level problem, but that I think is, again.
But those are private. What's the issue with those? They're not public.
Sure they are. Thing 2 gets new thing 2, right?
Oh, I get it. You're saying they're interfaced to public. Got
Yeah,
it.
so I clean up.
Got it. I got it. I got it.
Yep, and then. Whoa, hold the phone. No, they aren't. Oh, because. Wait, what?
What did you declare them as? I got to look at the declaration.
Protected.
Yeah, perfect.
So they aren't actually exposed. Okay, so so ignore that. I just want to confirm that this guy squawks at me for the same reason, right? Is inaccessible due to its protection level. Okay. Finally, something that behaves the way I would hope.
Okay, so we're back to the thing. There's only one thing that is not reasonable, right?
Yes. Well, one thing that doesn't work. Whether doing this is reasonable, I think, is a different discussion.
I don't know. If you look at that set of code, first of all, look at thing 1. That's pretty good for dispose pattern.
Yes, it is very clean. I might even go as far as to say, rather than making this one abstract, I might even go as far as to making this virtual with an empty body.
Yeah, maybe.
Because I feel like the unmanaged reference case occurs significantly less than the managed case.
Yeah, no, that's fair. But what I'm saying is, like, from now on, I would feel comfortable always using that class.
Yes, when possible, right?
I think I'd probably call it disposable rather than cleanup, but yes.
Fair. I was just trying to differentiate my names.
No, I agree. I know. But I'm trying to say, is there are we making an API here that would be reasonable? And so far, I think the answer is yes. If you're willing to use up your one and only inheritance, this is a reasonable approach.
And I think, and I would agree, because I think there's a lot of classes where I have gone through and implemented the iDisposable pattern as an abstract base for that exact reason, right?
Yeah.
I wanted an easy way to implement dispose, and I was tired of all the boilerplate, even with an auto-gen.
So now let's go to your dispose method. How's that declared? It's protected, right? And it's at interface level?
Oh, protected at the interface level, correct.
How do we make it so you can invoke that guy?
I'm open to suggestions.
Okay, so the worst one is you can do it. Oh my goodness, that's not going to do it. So the one thing to know, I don't know if this is going to help us, but the interface can call it. So you can't call dispose, but the interface can call dispose.
Right, clearly because it's being done right here, right?
Right. Well, I just want to point it out because you want to know how to get it to invoke. So can we define a method like an interface method that could invoke it?
So I think the answer is yes, but by doing so, doesn't that mean it's available outside, right? Doesn't that expose us to the same protection problem? I guess is my point.
I'm trying to define a protected method that I can invoke. No, if you what if you have a virtual method you could call? You can't call base, right? You cannot call base.
Base goes up your object hierarchy, not into interfaces.
Right. Man, it seems like we're so close.
Interfaces, thou art evil.
Oh, I don't think you want to say that. You certainly don't want to go on record saying that.
It's a good point. Must edit video. Add that to my list.
Yeah, no, I definitely don't think you want to go on record saying that interfaces are evil. Oh my goodness, that would be bad.
Okay, so while Mark thinks on that for a moment, I have a question for people in chat. Would people use a base class like this or an interface like this, assuming that it was working? That would be my question. Because I know I would theoretically use it in place of my, disposable object, but what I do in my projects, I don't think is fair to say is common. Kelly, I don't know what S means. Is that sure? Or don't come near me with a 10-foot pole? Yeah, so interface maybe, base class, nah. I'm guessing you're watching.
I still think I would use whichever one I could. I would use the base class whenever I could, but if I couldn't, then I would go ahead and use the interface. And remember, you're not going to have a version incompatible change if you change your mind.
True.
So you could actually go ahead and derive from cleanup, and then at some future point you actually needed to do inheritance back, you could switch. And it would not be a interface breaking change, an API breaking change.
I'm curious now.
How do you call a protected interface member?
So this is the other interesting one, right?
By the way, I'm sure people have told you this, but watching your Twitch stream with your face and hearing your voice is very challenging. Because your face is like 10 seconds behind.
Not for me. See, the other thing that I don't know if it makes me very happy is if somebody were to go through and say implement the dispose overload, right? Because they want to do their own thing for whatever reason, right? They can't actually...
They can't implement it. It's not virtual.
This guy doesn't get called from here?
You can't override it.
Can you get away with that?
What are you saying?
So the beauty of the default implemented members, right, is that in theory, if somebody doesn't like your implementation, they can put their own in its place.
Yeah, but you don't want them doing that in this case.
I don't disagree that I don't want them to, but they can, right?
No, they can't.
They can't do this one, but they can do this one. Right? Like I may not be able to do this, but I certainly...
So what if you did do what we're suggesting? What if you actually went ahead and declared it as new?
Like this?
Yeah.
How does that get around the fact that I can still hijack it?
You can no longer call it except through the interface.
You can no longer call it except through the interface.
You can't change it. It's not virtual.
New drops the virtual.
Yes, it's a whole new method. So there is a way to do it, just to be clear. You could go ahead and implement iDisposable.
Right. Right, and explicitly say, bypass this one, go to the base. Right, so what you're saying
you can't go to the base because that's private.
Right? That's still a thing.
No, you can't do that. It's
Sure I
private.
can.
Oh, yeah, on the interface, yeah. If you do explicit implement on the interface, that's exactly right.
Yeah, I can bypass the new and say nah, and go straight underneath.
But I think again that this still seems to me this is you have to know a heck of a lot no matter what, and we have made how much you have to know way simpler to the point that you would actually have to know a lot to be able to break this.
So I like the extension method that we wrote, right? Like this makes me happy because this gives me a nice generic way of going through and making sure, like if I really, really, really want to make sure that my dispose gets called because I've got something that matters, right? I think you can do protected static.
I got a question. Could we use extension methods to invoke dispose?
Extension methods to... you're going to have to explain. I'm not sure I follow.
Could we write an extension method on that takes a I cleanup? Although it would have to be public. And nestle is on a nested class. What I'm trying to do is allow disposable to call, figure out a way for disposable to call dispose in the constructor. No, sorry. Your thing2 to call dispose inside the constructor.
Sorry, Keith has an interesting idea here. I'm curious. And Kelly has a horrible idea. That's an interesting idea. Because then from here, right?
Right, you can invoke it.
Yeah. See,
But why take a thing? You don't want it to be thing. You want to have, yeah, so there you go.
Yeah, so you do thing, this, right?
That was my point of making that an extension method, but I agree, it doesn't need to be an extension method. Oh, I know why it'd be the extension method, because then the brace class can just call it. The derived class, sorry.
All right. Whoop, 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 whoop. That's an interesting idea.
Can you call dispose now? Can you try it? What happens?
Call this new static one, you mean?
From thing2, can you call dispose? Yeah. What's the warning?
Name dispose does not exist in current context. So let me clean up a couple small things here real quick that just to make sure we aren't getting bit by something else. What is disposable dispose? Oh. I clean up dispose. And get at it that way. That's a clever way around it.
But you made an extension method. Then you wouldn't have to preface it with I cleanup.
I don't know if you can do that though, because once you make an extension method, you're in a static class, and then you won't be able to touch the protected member.
You can if you put it as a nested class.
Are you seriously proposing it go here?
Yes. Well, seriously is a push. Seriously would be pushing it. I'm not sure the word seriously is right in this context.
for some reason in the back of my head, it's telling. Something reminds me that extension methods can't be in nested ones. Yeah, extension methods must be declared in top-level static class.
Well, that's dumb. Why would they do that restriction?
Because I've tried to do that before to get away with it, and you can't do too wacky of things with the extension methods, which is usually okay, right? Because you're not trying to hide them. This doesn't feel horrible to me, right? Like,
hold on one second. Can you go back to your dispose implementation?
Mm-hmm.
The static one? What if we didn't? What if we made that instance rather than static, and we didn't call it dispose?
So I'm not entirely sure how to do this, but my gut says something like that.
You're saying you can't call dispose? You could not call it without the prefix, without the fully qualified.
Yes.
We're going in circles.
Yeah.
You can't delete you can't delete the this there, right? Is that true?
Correct.
Because it's protected.
Yeah.
That restriction, it's been baffling for me for a long time. Why did they make it impossible to call a protected member?
Because the people who put implemented protected members on their interfaces are crazy. Just like
but you don't care. This is not an implemented. This is not. Why? That's how our abstract classes work normally.
Right, and this is why I don't like default interface members. Is the protection levels on them are baffling.
This is true. I completely agree. But what I'm trying to figure is why did Microsoft make it so protected members could not be invoked?
Well, they're not. So it's not just protect. So, because I will point out that, right, this is protected.
Yeah, I agree. Yeah,
so,
I agree. Protected instance members.
Something in the back of my mind says that there's some sort of conflict with that, right? Of how do you do your method resolution at that point? Jared would be a good one to ask on this.
Okay.
Yeah, I'm still not. The interface is nice, but it still requires a lot of effort.
I think the class is the way to go whenever you can.
I don't doubt that the class is by far the cleaner option, right? It just has the problems of an abstract base class, which means it's not usable everywhere. Because I don't control the whole hierarchy.
Let's be serious. The number of times you have classes that derive from other classes and do cleanup is not that common.
How many Ienumerables do you write? I think that's my most common use case, right?
So you'd write an Ienumerable, disposable.
Right, and in that case I can still derive from this, I guess. So that works. That's a bad example.
I just think it's fairly rare that I'm writing a class hierarchy for something that is disposable, unless the purpose of doing it is to provide disposability. So I write base classes that are disposable when the purpose of doing it is to be disposable. In this case, we've provided that class.
That is true.
And the other thing I would do here is I'd probably go ahead, I think I'd still refactor I'd refactor my cleanup class, which I think is now called disposable.
No, it's still cleanup, right? To make it iCleanup.
Okay. No. I was gonna. Yes, exactly.
Right? So that guy goes like that. What are you wanting to implement? Oh, yuck. Oh, this Boolean is uglier than I'll get out. Not a fan. Not a fan. What are you still unhappy about? I dispose set cannot be implicitly implemented in a non-public member. Oh. Again, yuck. Just gonna say that.
Can it be protected?
It technically the setter is protected. You just can't tell. That means this guy goes away. Constructor stays there. The dispose implementation goes away. This guy stays here. I am realizing we could kind of get away with not needing the GC suppress finalize, right? Like theoretically we could move that inside. Nope, that's not the copy button. Right? So in theory we could move this inside of this guy. Be done with it. Right, I think I'm going to do that just so my derived class no longer needs to do unmanaged when it doesn't care about it. Let's see, disposed managed. Oh, yuck. See, now we have a problem.
The problem is you have to implement those. Is the class abstract?
It is. And I mean, there's no reason I can't just forward over, right? Like,
Just delete them.
like that, like this works. It makes me feel dirty.
Why can't you just delete it entirely?
Because default interface members are
Because
dumb.
you're implementing
Right?
Yeah, because you're implementing the interface.
Yep.
Again, nobody sees that code. You don't care.
I kind of care.
No, you don't.
Suck. Why is it forcing me to implement this one? That shouldn't be required, right? Because that one actually does exist. Can I get away with this? No. Because those ones, the difference between the...
Because you said you implement the interface when you don't.
Yeah, because the dispose one has an implementation, these
Right.
ones don't.
Right. I still think it's reasonable. I think you're totally fine with that. Except now in implementing classes, do they know, does a person implementing, deriving from this class know that they have to be implemented?
Know that they have to do this?
Yes. If you
Like-
delete one of those, stop compiling?
Well, yeah. I mean, well, let me rephrase. It'll squawk at one of them, right? It'll require that you implement the managed side. Because I made
yeah,
the
so
unmanaged
that's
one.
What we wanted. That's what we wanted. That's good.
Yeah. So that's the bare minimum you can get away with now, right?
That seems pretty good compared to what we had.
And again, the abstract base works and works well, but it has the problems of an abstract base.
That is still way better than what we had before.
Yeah, I think I need to use it. I'm on the fence.
From a
Because
unit
the
testing
other
perspective.
thing that I'm still considering, right, is if I need to have something that I'm disposing that exists outside of myself, right, before I would use this. Let me rephrase, exists outside of my process.
You need to have an unmanaged resource.
Well, but even beyond that, right? Because if all it is say an unmanaged pointer, my entire heap that my process was allocated is about to get cleaned up by the OS.
But that's missing the point. You don't need to worry about stuff that we've already got classes for. Safe handle already handles that.
Right, but I guess that's the point, is it's not just unmanaged stuff. It's something that has to live outside of my process.
It's something that memory management will not handle and is not already being got an appropriate dispose implementation on it. At the end of the day, that's the only requirement. This is an object that does not already have a dispose implementation on it.
That is true.
And if you don't have that, you really don't need to, you're not worried about unmanaged, period. The whole problem goes away.
That is true. I do wonder too a little bit about the memory pressure that we're allocating as well, though. Right.
What?
So, say that something a derived class is used, I don't know, in a list of 10,000 thingies, right? We're still allocating a weak reference object, which by itself is very small, and we're still allocating a delegate for every single instance. And I don't think you can get it, like, I could take the delegate and put that into, say, a static function, right, to avoid some of the allocation. But ultimately, I have to have something that holds on to this weak reference.
Yep.
I could get away with a single allocation into process.exit by pointing it to a static function and having a list of these guys that I hold on to. That would be smaller, but it would have the resizing bits of list. Yuck. Because this does add some level of overhead, calling the register for cleanup.
I guess you're right.
And
maybe
it's not a big deal, right? But I do want, like, I feel like if I'm going to use this class somewhere, I want to be very careful about where it gets used.
I think my comment about this, Kevin, in the real world, there's a serious shortage of objects that need to have this implemented on them, and I can't imagine you having 1,000 of them. Never mind some significant number.
I might want to go through and actually query some of my repos and see how many iDisposable implementations there are of my objects, right?
It's not implementations, it's instances.
Well, right, but if I find all of the things that implement iDisposable, then I can just see how many instances of those things I'm creating.
Right. That's the point. Well, my point is, I don't think we're creating that many instances of something that has to be. And no, hold on. That's not true. It's not iDisposable. It's iDisposable objects that are there because you have unmanaged resources.
That's true. The other thing we could do is
you got an unmanaged resource.
If we change this from iDisposable, we could also unregister the delegate. Right? Because We only
So when you do
care.
GC suppress, we should also do this. I totally agree.
Yeah,
It,
because it,
in fact, I think that's a mistake not to have done that. The problem is keeping track of that item in order to unregister it is hard.
right. Well, I think what I would do is I would not do this in an extension method, right?
Yeah, no, I agree.
I
You
would
don't have
move I
a
would
choice.
move this up that way I could hold on to the delegate instance to be able to
You don't have a
unregister it.
choice. You don't have a choice. You don't have a reasonable choice.
True. And actually, does that mean no? I was going to say, does that mean we need the weak reference at that
Yeah,
point?
you do because process exit is still pointing to it.
Yeah, yeah, because I definitely don't want to hold on to it forever. Well, cool.
I think it's fun. Thank you. That was
Yeah,
good.
I think that's probably as far as we can take it tonight.
I
Hopefully,
agree.
people found this to be interesting. So,
Thank you, Kevin. That was fun.
yeah, no, thank you, Mark. So, with that, I will say good night. I'll hopefully have this video posted to YouTube tomorrow-ish at some point.
I will probably be writing this up over the next 2 weeks.
Excellent. There will be
Actually, Mike, I've got a specific request from the C# team to write this up.
excellent. Once you do, let me know. I want to put a link to that because I assume that's that GitHub
No, no,
issue I
you don't
saw.
understand, Kevin. Once I do, I will let you know so you can check it for me. What are you talking about?
Of course. Perfect.
No, I think this is a challenging problem, and there's actually a specific article that we're trying to get that I need to edit because it doesn't just talk about this correctly. In fact, it's the one I linked to, right? I've
Yep.
got a I've got an issue posted against that article. And unfortunately, it's one of those times where I posted an issue and they came back and said, "Okay, Mark, go ahead and write it."
See,
Careful what I say in the future.
that is the problem.
Yes, be careful what you say.
Yeah, if you complain, they're either going to, let you do it
Oh,
or tell
gosh.
you you're wrong.
Yeah.
So
Well, it should be easier. My book is like pregnant, so we're close.
that would be awesome. Cool. I'm going to say
Good
signing
night.
off, and we'll have a good
Thank
night.
you. Thanks everyone. It was fun. That worked well, Kevin. Nice job. I was so excited about the weak reference because that's the thing I really wanted to try because I knew that this problem existed and I knew the way to solve it was with the weak reference. Yeah. Yeah, send it to me. Just send it. I mean, you can just copy it and paste it in an email. I don't need anything besides that. Yeah, that's fine. How'd you send it to me? How did you send it to me? Oh no. That's a terrible way to send me a file. What were you thinking? Where the heck does that go? No, I mean, where does it actually, when I save the file, where does it actually save to? This is a, oh my goodness. I've now got a file called program.cs and I'm supposed to know what it's for? Thanks a lot. No, I'm kidding. Thank you, Kevin. That was fun. I enjoyed that. Yeah. Yeah.